Hi everybody, so welcome to lecture 5.1. This is 5.1 and hopefully I'll also do 5.2. I'm really excited about this, so let's get into it. 5.1 has to deal with properties of continuous probability distributions, so and the different types. So the graph of a continuous probability distribution is a curve, okay, and if you recall from previous, probability is represented by area underneath the curve, and the curve is called the probability density function, and we're going to look at, or PDF, and we're going to look at different examples. We often use the symbol f of x to represent that curve, and f of x is that function that corresponds to the graph. And so let's continue to see what types there are. Okay, here's some properties of continuous probability distributions. Remember before we went over discrete, where we could count. The outcomes are measured, they're not counted. The entire area under the curve and above the x-axis is equal to 1. Probability is found for intervals of x values instead of individual x values. So here's an example. You're finding the probability of x between c and d. That's the probability that the random variable is within the interval between the values c and d. And then you have the area under the curve, okay, to the right of c and the left of d. So it's kind of like, you know, here's c, here's d, and then you have some function, and here's the area, okay. So if it's equal, the probability that x takes on any individual value is 0, because the area under the curve has no width, and therefore it's no area. Okay, and this is for continuous. So then this is the same as, so less than or less than or equal to, in this case only, is the same because the probability of that is because the probability is equal to the area. Okay, so let's define one. So remember, f of x is how we define that. So remember that we define the function f of x so that the area between it and the x-axis is equal to a probability. The maximum area is 1 because the maximum probability is 1. And so for continuous probability distributions, probability is equal to area. Okay? So here's a super fun example. Okay? So consider the function f of x is equal to 1 over 20 for x is between 0 and 20 inclusive. So x is a real number, right? So here we go. Let's just look at this right here. We have the graph of f of x is equal to 1 over 20. That's just a straight line, okay? That's just a constant. Okay, so since x has to be between 0 and 20, the f of x is restricted to this piece right here. So it kind of looks like a rectangle, okay? So, right, so the graph is a horizontal line segment. Now what's the area? So the area between f of x is equal to 1 over 20 and it's basically the area of this rectangle, okay? That's the area here, right? So remember the area of a rectangle? Is base times height, right? Okay, so just for remembering. So the base, so this is my base, and this is my height, right, of the rectangle. So base is 20, right? So base is 20, and the height is just 1 over 20. So the area underneath the curve, the total area, would be 20 times 1 over 20, which is just equal to 1, okay? So that's that. Let's continue. Okay, so what if I wanted to find the area between f of x is equal to 1 over 20 and the x-axis where x is between 0 and 2? So now the base is shorter, right? So basically you have haha. So you have here, the base is now only 2 units, right? The height remains the same. So here we have base times height, which is just 2 times. So your base is now 50. We call this so your area is to represent the probability. Okay, so the probability on 35 are the number of passengers on 35 different charter fishing boats. The sample mean is 7.9 and the standard deviation is 4.33. The data follows a uniform distribution where all the values between and including 0 and 14 are equally likely. So let's take the values of A and B and let's write the distribution proper notation and calculate the theoretical mean and the standard deviation. Okay, so A, what's the lowest value here? I have 0, right? So A is 0. And what is the greatest value I have is B. Okay, so my range is from 0 to, so you'd say X is uniformly distributed from 0 to 14. And what is my mean? Remember the formula. Sorry, it's giving the answers away, haha. So mu is equal to A plus B over 2, and then we have standard deviation is equal to square root of B minus A squared over 12. Okay, so if we plug that in, 0 plus 14 over 2, that's just 7. Okay, so there it is. Doesn't work actually, I was just doing it. And then sigma, or the standard deviation, is 4.04. So 0 plus 14 over 2 is 7, and then 14 minus 0, take the square of that, divide that by 12, and then square root all of that, and that will give you 4.04. Okay, I think I have one more example. A distribution is given as X is uniformly distributed from 0 to 20. What is the probability of X going from 2, is between 2 to 18, and find the 90th percentile. So the notation is this, right? So since f of x is 1 minus b minus a, 1 over b minus a, sorry, just from looking at it, a is 0, b is 20, correct? And then we have f of x is going to be 1 over 20 minus 0, which is 1/20th, right? So there we go, and so that's it. But remember the formula for to find the probability, it's the area, right? So this is the height and this is the base. So it's like base times height, but it's, flipped. So we just plug it in, right? So f of x is 1 over 20, and then we have the, we just do, b minus 1 over 20 times d minus c, which is basically, this is my c and this is my d. So, the distance that you're finding the area over is 18 minus 2, which is 16. So 16 over 20 is 0.8. Okay, so p of x between 2 and 18 is going to be 0.8. Okay, so to find the 90th percentile, we set the probability between c and some unknown d to be 0.90. So basically, we're finding this here. We know that the probability, we want to find the 90th percentile, right? So that means that the area underneath the curve is 90%. Okay, so this area is going to be 90, but we don't know what the value of d is, okay? So we're saying, okay, what is d if p of from 0 to d is equal to 0.9, okay? So we know that the probability for x between c and d is equal to f of x times d minus c. Okay, so we know that f of x is equal to 1 over 20. So we're just plugging it in. So 0.9, this represents the percentile, is equal to 1 over 20 times the quantity d minus 0. Well, that's just d. So 0.9 is equal to d over 20. Multiply both sides by 20, and you get that your d value, this should be lowercase d, is 0.9 times 20, which is equal to 18. So 18 is actually your 90th percentile. So, right, so in this case it's from 0. So you might think, well, it was 18 over here. Yeah, it was, but remember, c was 2 over here, so it's different. Okay, so we're basically saying, okay, here's my graph. What's the value so that this is 90% of this? Okay, at what value d will the probability between 0 and d be 90? So 90%. So there you go. That's all I have for 5.2, and your homework for 5.2 is somewhere that I conveniently placed and then lost again. Here it is. So practice 5.2 is from 17 to 45 odd, and then 5.1 is 1 through 15 all. And we will submit via Canvas. Okay, so upload document, and then I think we're going to skip 5.3 for this chapter, so we're going to come up on a quiz. So quiz on chapter 5. It's very short. It's only 7 questions, and it's going to be taken on Canvas via Newton. Okay, and I will upload that probably tomorrow. And during class I might have any questions. So class will be tomorrow. So class via Zoom Tuesday. Okay, so this Tuesday, and I will go over any questions, go over any homework questions that you might have, and also have a little quiz review for you. Okay, so I will see you guys on Tuesday, and I hope you have a good day, and I will see you tomorrow. Okay, bye.